welcome everybody to our AR for VR Rhino user group meeting, the second one we've had this month. This evening, Steph and I are joined by two guys from AKT in London, their Parametric Applied Research Team of AKT in London. We have Julio and Joel, who will be presenting first. Secondly, we have Vittorio here as well. Vittorio is from Mindesk and will be showing us the very latest developments of their plugin for Rhino. And we'll see as well that there's a link in some of the project work between the two organizations, which is nice. So perhaps we'll have some discussion about that after each presentation. Please, I'd just like to encourage anybody, if you have any sound issues at all, put that in the chat and we'll do our best to kind of help that. There's always one or two perhaps that have an issue, but it's normally very quickly resolved. Questions are really important to us. We'd love to have your questions. Feel free to just type them at any time. Some may be answered in text, or we will read them out to each presenter. So the guys from AKT will present, we'll ask them some questions, Vittorio will present, and then we'll ask questions of him, but we'll all join together as a group at the end as well to have some further conversation and Q&A. Please bear in mind that this is all recorded, so just like the meetings that we've recently had with Heatherwick Studios, and others, although all those amazing meeting recordings and the full transcriptions as well of these meetings are all there on our website at rhino3d.co.uk. So we can send you links to these things, but so this meeting and previous meetings are recorded. So I think that's all I want to say for now, and I'm just going to hand over to Joel and Julio. Okay, and I'll see you after their presentation. Thank you.
Thanks, Paul. Let's see. Okay, yeah. Hello, everyone, and thanks for having us. Yeah, as mentioned, my name is Joel, and I'm here with my colleague Julio. And we're from the Applied Research Team at Engineers AKT II in London. And yeah, so quick background on us. You can flip the slide. Yeah, so we're from the Parametric Applied Research Team at AKT II. And yeah, we're the in-house computational specialist team at AKT II in London. And yeah, we're a cross-disciplinary group consisting of architects, engineers, software developers, computational designers, where we try to capitalize on technological advances and software development and computational design within engineering practice. And in general, the team is kind of split between research and development of tools, plugins, interfaces, but mixes a lot with project work. And we try to work both with the structural engineering side of things, but also with that kind of bioclimatic team and the CFD, etc. But yeah, as you can see from this image, projects and the kind of applications is a key driver for us. So we try to really engage with project work and let that kind of drive the developments that we do. So we're really kind of an applied research team in that sense. And yeah, I try to work, both small and larger scale. Yeah. So what we will talk about today, just to give a quick overview, we wanted to talk a bit about kind of general workflows and exchange between software within an engineering practice, specifically dealing with kind of complexity and visualization. So yeah, we'll start a bit with a quick overview of kind of the processes and tools we use on the day-to-day and show some real applications, and then kind of move into a case study of a timber gridshell. And yeah, just in general to mention the topic of VR, given the context, it's something that we have worked on in the p.art team before, both as a kind of research and in project applications. For example, you can see here like the Head in the Wind sculpture with Alan Jones and the tide on Greenwich Peninsula, for example. And yeah, like ranging from objects to more kind of master plan level. And when thinking about this in this context, we kind of wanted to zoom out a bit and look at more kind of the wider kind of design process and what we do. Because I mean, a project moves through many different stages, takes many different modes and forms. And along this way, information is generated, presented, and exchanged in various ways. And what we see like with VR, it's often used kind of in latter stages in kind of presenting a product, in presenting some sort of outcome, and to very much like work as a container for presenting results or whatever stage of a project. So like leading up to a more VR-centered presentation by Mindesk later on, which we actually collaborate with, but I'll get to that. We want to kind of take this opportunity to maybe flip it a bit and then talk a bit about kind of the back end and the kind of general stuff we do as an engineering practice and how this ties into kind of how we produce and manage data as part of our workflows, which is then what's collected and kind of presented or packaged or communicated. What are the kind of containers we work today where things come together. And yeah, as mentioned, we have recently started actually working on a research on a VR platform together with Mindesk. And I think what we realized part of that process was that like we need to understand all the steps and actions in order to understand what VR can do for us. It's like what we actually do and what's the kind of information we need to exchange or present. So that's what we wanted to focus on today. And this is something we have done quite a lot at AKT, and also kind of linking together and exchanging information between software, between practices. And we have been developing for a number of years our React, which is our own interoperable ecosystem, which allows us to kind of exchange data and models between the tools that we use. And yeah, to get a bit more specific, let's see. Yeah, so like this, the kind of range of software we usually look at and we usually use for different things we do as part of our day-to-day work. And it's analysis packages like structural CFD, or geometry, which is like Rhino and Grasshopper, obviously, but also like Unity and kind of moving on to BIM. And everything is kind of facilitated using our kind of AKT core library, which is kind of our software agnostic intermediary, which we use to kind of convert back and forth between all these native types. To develop our own tools, we kind of use this as a basis for kind of linking it with the wider kind of spectrum of tools. And yeah, just to kind of go even deeper, like often when we apply this, like we use, Rhino and Grasshopper is really kind of our hub, which we often start from and to which we often kind of come back. And then we kind of exchange the information back and forth to and from Grasshopper, either as kind of serializing formats, bundling that sent to specific apps, or kind of sending it to commercial packages by tapping into APIs and kind of really live links, which is also something that I think Mindesk will show you later, to get a kind of frictionless exchange. But then we often like really find ourselves streaming all of this back into Rhino and Grasshopper again, because it's nice to visualize, and it's also a really nice tool to kind of process and help us understand what it is we do and what is it like we're engaging with. So I think in the following case study, we wanted to expand a bit and go into a bit more detail on how we do this.
Yeah, so today we thought we'd bring a nice case study project. We think it's always quite nice to have a look at actual projects to give an example of how these workflows are applied in practice. This one's a recent one in the team. It's a luxury resort, and as you might have understood from these beautiful shades of blue, it's in a nice coastal location. The buildings we'll focus on today are that group of 6 buildings right there at the bottom in that triangular shaped island. They basically form the entrance gateway to this beautiful ring of water villas on stilts. And they're composed of a sort of a mix of front of house and back of house areas, open and semi-open vaulted spaces. The main aspiration for these structures from both the client, the architect, very, very early stages was to sort of achieve this sort of barefoot experience. So something that the guests could actually feel. They wouldn't necessarily feel in a high-end luxury resort, but just sort of very in contact with the beautiful beach and the nature. we sort of try to achieve that with sort of as lightweight as possible and as no frills as possible architecture and structure. As you can see from the renders from the architect, most of the buildings are sort of semi-open or entirely open, and just mainly clad with rope. So the sort of that feeling was definitely a huge driver in the design. Other drivers in the design were definitely site ecology. It is a it is a site with a very fragile ecology, and we sort of tried to maintain that as much as possible. Looking at regional resources was obviously another big driver, and considering the local climate, which structurally can also be quite challenging. The sort of high temperature range fluctuation, high UV exposure, surprisingly actually quite a dry environment, but sort of the local climate, and the barefoot experience again, which we just mentioned, that was also a big driver. How do we respond to these design drivers? We've tried to favor as much as possible prefabrication and off-site manufacturing, which we won't dwell on too much today, but was definitely a big part of our design, together with a sort of modular approach, where, I mean, on a structure like this, it's actually quite hard to achieve an entirely modular approach, because most of the elements there are quite bespoke. The geometry itself is quite bespoke, but we did sort of try to achieve a sort of a repetitive process more than the sort of product. The final output was a series of lightweight timber structures, which we took inspiration from many sort of illustrious precedents out there when it comes to timber grid shells. In the UK, just to name a few, I mean, the Weald and Bowlen grid shell, or the Savile building one, and obviously we have to mention the nice Frei Otto Mannheim multi-halle. I mean, grid shells are a great way of sort of achieving these very large spans with a very sort of lightweight minimal structure. They do come, however, with sort of quite an intensive sort of analysis, form finding, sort of computational overhead in a way, and that's actually where we saw a lot the opportunity to sort of to use of course the usual suite of Rhino, Grasshopper, parametric tools, but that's where we think that then sort of some advanced visualization during the design process through VR, AR, any sort of mixed reality could really sort of give us an edge in the design of these grid shells. So visualizing them was definitely going to be a key factor in there. The buildings themselves, there's 6 in total, 2 different typologies you can see here. The 2 different typology are composed by what we call a lattice grid shell. So this is like an elastically bent sort of grid shell formed by these very thin timber laths. These are framed from glulam arches, and they sit on a nice sort of prefabricated steel base grillage that could just be sort of dropped on in place, with some precast pad foundations, again, to sort of minimize work on site. And the other typology is a pavilion, what we call a pavilion. Sort of, again, has a timber grid shell, but is very different. The way it's working structurally is formed by straight, discrete elements. So each one of those is a single sort of beam in a way. And the way we achieve geometry, or sort of the desired geometry of the vaults in that case, is actually through the sort of complexity in the node connection. So 2 very different ways of achieving a vaulted space. Today we're just going to dwell a bit more on the lattice grid shell, because it is actually quite challenging, sort of both form finding wise and then analysis wise. So now we're going to look at that sort of the design process and the form finding.
Sorry, so if we start to get into the specifics of this process, and given this kind of topology and the challenges that comes with it, it's clear that we kind of have to move through loads of different steps and loads of different packages, but that would all be kind of very clearly linked together. And this is going to really require these kind of quick and seamless exchanges between analysis, between geometry, and also between kind of BIM and documentation, because already from the beginning we're going to have to consider what are the material and like already what are the stresses from this kind of bending, and like the kind of structural performance already as a first step. Like even as we just start to look at kind of the surface and what properties does this one have and what properties does it need to have, and kind of what can we do, and like how do the architects feel about what we can do, etc. And then kind of moving on to kind of finding this geometry and finding the right curvatures, which then we'll kind of need to consider, okay, what's the stress and what's the maximum thing we can bend these things. And once we have some idea of that, we start to feed that into a finite element model, a geometry model, again, carry out the analysis that we do, and then we kind of figure out what maybe initial section sizes, etc. we have, which then also need to kind of be fed back into the initial geodesic grid to kind of figure out, is this feasible or not? Which wraps the whole project through all these stages into a very kind of closed feedback loop, which has to be resolved iteratively. Like there's no real way you can know for sure what you're going to need in when you start to model it. Yeah. So, and if just start with talking about just the geometry. So like this was the kind of basic premise of what we had to work with, and with the overall boundaries being rather constrained. Like the freedom was mainly in how we construct the surface, how do we place the grid, and then how do we tweak this in order to make sure that it all works out nicely in the end. Because I mean, as engineers, we still have to do modifications and tweaks and try to kind of make the geometry work in our favor. And also kind of depending on what we learn from exactly what's the curvature like how can we place something on this thing, and how do we kind of make it clear to the other partners that we work with what's possible and what's not. So for example, in the beginning they wanted this kind of fanning lats, but it was never going to work, because like the way you want to construct this is you want to lay the lat with the kind of deep dimension in the plane of the surface, which means that you can have to look at two different curvatures, like how does it curve in the plane, how does it curve outside the plane, and then kind of feed that back into what's this lat, and how can it actually work. So yeah, and also kind of to find a nice ordered grid from this. So what we did in this case, we tried to just find an analytical shape which we can use to kind of fit to this, and it fit quite well actually, and then use that to kind of drive a very like geodesic and nice curved grid along this ellipsoid, which we can then kind of project back to our form and then use as a starting point when we try to model this. And yeah, moving on. So from this, of course, we then use all these tools you have in your own Grasshopper. For example, in this case, weigh all these stresses that we don't want to make sure that we have a grid that's has as little stress as possible from the beginning, like because we know it's going to have to take additional loads. And yeah, so as you can see, we kind of ended up with a nice even grid despite from the relaxation, because we had this rather rational underlying logic. Yeah, and if you take the next one, yeah, and then kind of all this feeds into all the modifications that we do, like how can we then tweak the surface, how can we run through it. In this case, we just use Galapagos to kind of try to optimize and just find some nice surface which has the kind of within the right domain when it comes to stresses and curvatures. And it's like, and then when you have this whole and complete process, obviously you don't really know what's going to work. So we find ourselves just going through countless and countless iterations where all of this kind of what we realize at the end sort of feeds back, and we tweak the form, and we tweak the grids, we tweak the lats, the section sizes change, and kind of all of this needs to be communicated and displayed and then kind of understood by not only us but also everyone that we kind of work with. Yeah, let's see. Yeah, and like in relation to this, there's also a lot of kind of detailing that's going on, which in relates a lot to kind of what kind of forms we do relate to what kind of details we do. And like this is also like this kind of visualization problem. Like we have to also communicate with each decision we make what are the other implications of that, and how does that then relate to the details, and then the kind of look and feel of this whole thing as we reach the final configuration.
Okay, on to how we actually sort of carried out the engineering analysis and structural design of these grid shells. I think an interesting thing to note here is that, yeah, I mean, as engineers, we sort of tend to use quite a lot of different programs in what is sort of most of the time quite a fluid, but nicely, well, actually a rather chaotic workflow. We usually end up using sort of finite element analysis package, where it could be our SAP, robot, ETABS. We're quite sort of software agnostic in that respect because of the sort of React and our AKT core libraries. But so we tend to use an FEA software package, and as some of you might know, these don't tend to have the sort of the best GUIs out there. So that's always quite a challenge. And if you sort of pair it up with then using quite a lot of bespoke element design tools, it could be, you know, that little spreadsheet someone did and you're sort of recycling many times, or maybe it's you know, it's a special program that's just designed to do special checks on specific type of elements. It could be the sort of Jupyter script or Jupyter notebook that we write. We tend to sort of tend to combine a lot of these quite chaotically sometimes, and what we do lack could be the sort of the crucial graphical feedback. I mean, if you compare, especially in a multi-dimensional project, sort of where you're actually looking at maybe, you know, dozens of look combinations or directions, you know, the issue really does become multi-dimensional. Visualizing the results, not just via tables, so just a numerical output, but trying to sort of understand more sort of empirically in a way the performance of the structure, especially on a structure like a timber gridshell, where the sort of the structural performance is so related to the geometry and the way we define that, as Joel showed you guys. I think, yeah, we really sort of we need to have that visual cue, and that's why we tend to sort of then re-import all of our results back in Rhino. So you can see here again, all of the in this case SAP results are brought back in to AKT core elements, which we then sort of preview directly here. And what this means then is that really just a sort of few set of components, we can bring back everything entirely in kind of our preferred workspace, and it is one single workspace, so we can then sort of carry out all the different checks. So we've effectively combined the work of, you know, the FEA model GUI, and at the same time all of our little spreadsheets and other design tools all into one place, and that especially for timber gridshell is really, really important. So the reason why we wouldn't just be able to do this with, say, our typical FEA software is that on a gridshell, the initial stress in the timber elements, so in these timber lats, is sort of induced by the fact that we elastically bend them and then lock them in place. So the sort of the initial state of stress when the sort of structure is completed is not actually zero, and that's not something we can capture in an FEA model. So the stress that is in the lat is sort of driven by three different factors. There's the sort of the Young's modulus, which is effectively driven by the material, and which is why going for timber for gridshells is, you know, particularly advisable. That's why most of the gridshells out there are made out of timber, because it's a very flexible material that can sort of doesn't then yield that sort of high stress when bent. The second one is the second moment of area, which is basically sort of a function of the depth of the lath you're trying to bend. Again, sort of people laminating plywood have known this all along, and that's why we sort of tend to laminate in very thin strips that we then kind of glue together. And that's the case particularly for gridshells, where you would try to sort of laminate smaller laths to then create your sort of full composite section. And then finally, the other driving element for the stress is the curvature, and that's a direct output of the form finding process. So that is sort of 100% geometry in a way, and that is the sort of thing we need more feedback on. We just can't understand intuitively by just looking at a tabular output. So you can see on the right hand side there the sort of plot of these bending stresses in these elements, and you can see the sort of more red areas as opposed to the more blue ones, and how really the sort of more blue laths are effectively the more straight ones. So really we get an immediate understanding of the state of stress there, and that means we can then combine it with the output from our FEA program. So we combine what we call the sort of forming stress and the working stress, again, in a very, very small sort of space of like computational space. So very few set of components give us really the power to do all of this, and then eventually preview these results. So like allow us to focus on a specific patch where we see maybe the local curvature there has been exceeded. We need to go back to the base surface and tweak it, or maybe we have to sort of look at the lats and their section depth and sort of tweak something there structurally and change the section size. So that sort of allows us to then sort of act locally on the model based on this sort of kind of immediate understanding we have looking at it. Yeah, so this is the overall result. So just looking at, in this case, we're looking at maps of sort of different element utilization. So the sort of how hard every piece of timber in here is working. And we get an understanding of this, again, just through the Rhino viewport. Really, this is the best place where we can see this. Yeah, so again, multi-dimensional issue with quite a few different load cases, quite a few different load conditions. We can all see it sort of readily in Rhino. Like to sort of, I think this is a good one to mention, just sort of almost to conclude. Yeah, just thought to bring it here. It's given the crowd probably appreciate the sort of Rhino Inside. I think we're all big fans of this, and I think what we wanted to say is basically because we've done all that work in sort of all that overhead was put into setting up our models using our kind of common core classes. Translating something from an analysis model to say Revit is actually very, very straightforward. So this kind of approach lends itself extremely well to then using things like Rhino Inside to translate all the geometry into Revit, which is effectively our sort of favorite tool to then document and share with other stakeholders. So in this case, yeah, we've whether it's a straight framing element, which gets with just a few inputs like the center line and justification parameters, gets brought in directly as a framing element in Revit, or whether it's a curved element that gets created from a BREP as a family. We managed, as you can see here, on the pavilion, and here on the lattice, you can see that this sort of that workflow is actually quite seamless. Yeah, we can really import pretty much all of the elements we've created. So you can see from this view here of the BIM 360 model how basically, yeah, every single element we've created gets brought in, and not only gets brought in, but it gets brought in as a Revit native element, which is really important for us. So it's got all the shared parameters we need to have in there. So probably off topic, but we thought it was sort of interesting to show how sort of, yeah, all that back end work we do beforehand in our models properly, and gives us this sort of this nice kind of bonus in a way, this kind of nice addition to the workflow. Okay, conclusions. I'll hand over back to Joel.
We're actually currently engaged in a research project where we're working actually with, among others, Mindesk, where we try to bring kind of a lot of all this stuff and like all this kind of CAD stuff and computer-aided engineering and BIM into some sort of collaborative and shared space, which yeah, I think hopefully can then further extend all of the things talked about today, like how we can get like nice representations of and understand what we're doing and visualizing, and also kind of getting all the intelligence and data behind it into some common space. But yeah, so that's one to look out for. Still very early stages, but yeah, thought it was yeah, interesting to mention. Yeah, apart from that, I think that was it from us.
Okay. Fantastic. Thank you very much for that presentation. I'm going to, I think, show my screen now. Just one second. Okay. there's just a couple of questions. I think what we'll probably do is have more of a Q&A after Vittorio's, but I'll just ask a couple of things that have come up, if that's okay. There was a question, it's interesting to see Rhino Inside featured, mentioned in your presentation. Has Rhino Inside, I mean, I guess you started to use, you must have been using this while it was still in beta, of course, because Rhino 7 only shipped a few months ago. I remember Scott actually presenting Rhino Inside at your offices. That was a little while ago now. How far back does this go? There was just questions about whether it's found its way into other projects.
I think speaking for the projects in the company that I'm aware of, it definitely has found its way in more than a few. The reason that being that although we sort of tested a number of different workflows to bring everything in Revit, and we've sort of historically been using quite a lot of different of those. We sort of got engaged with Rhino Inside, so the beta version, quite early on, and that gave us the confidence to really sort of push that aspect. We sort of, in a way, we kind of came prepared to that in the sense that because we were already serializing and converting all of our geometry to AKT core classes, so our sort of common environment is then quite easy to sort of have a single translator to convert that to the Revit object. So I think it was. I mean, it's great, and I think we're just going to use it more and more of it in our projects. And that's why we sort of felt it was useful to share it in this particular case. I think it's probably one of the first early projects being released out there that are sort of using it fully, sort of 100%. So
yeah, well, that's good, great to see, because it's I remember it was in its very early iteration presented in your offices to a group of 100 people from the Grasshopper London group. So it's nice to see that it applied to you as much as anyone else that might have been listening on that day. So that's great. Just a question about, that was part of your presentation, you mentioned using, timber as the ideal material for the gridshell construction. There was a question about experience of non-timber gridshell structures. Is that something at all that you could comment on?
I think, we tend to see quite a lot of timber gridshells out there because timber lends itself particularly well for this application. And I know I can't really think of I mean, I'd be interested to see examples out there. It's perfectly doable. I mean, the structural principles would be exactly the same. So I'll be interested to see one. I'm thinking of an elastically bent gridshell because otherwise, I mean, we then sort of go to the more sort of space frame section, and there's just then plenty, of course, out there. But elastically bent steel gridshells, I'd be curious to know if the audience has ever seen one. It'd be quite,
I think I've seen one, but that's a kind of asymptotic one, but that may have been steel, but I don't remember. But I think it's still very few. Yeah.
Okay. Well, maybe the person will elaborate, I think, where the question is coming from. Maybe they have an example in mind. Okay. One of the questions, so how exactly do you achieve this Rhino interactivity? That's quite a broad question, I think, but I don't know, is there something you could attempt to, I think, parts of your presentation discuss that, but it's a question from Malgarazza.
I mean,
I'm sure I haven't pronounced that correctly, but yeah, sorry, could you have a go at that?
Like, as I said, we have our own kind of core library, which features an object model and a bunch of kind of conversion methods, and then like, which is in a sense not really Rhino specific in that way, but then we just kind of wrap those objects in kind of Grasshopper objects, and then you just kind of pull the strings with the components. and then you just build some, visualizations around that. So yeah.
Okay.
I think it's an interesting point, sort of Rhino in general, because sort of all the points we just made about our presentation and visualization, we carried out in Rhino, but they could have as easily been carried out in any other platform, following exactly the same process. So that's a sort of that's quite the nice sort of feature about all of this, is that if you do sort of go through the overhead of setting up your model properly, then really, whether you're visualizing it in the Rhino viewport or you are visualizing it on Unreal everywhere else, and I'm sure Victoria at Mindesk will sort of tell us all about it, but it can really be sort of anywhere.
Yes. And particularly, with this project, where was VR or AR used within this particular case study?
Yeah, so this particular case study, we didn't really feature any VR in the sense that we wanted to focus more on what's the process beforehand, before sort of delving into VR. We also thought that this particular project worked quite well because the sort of all the visualization that we have to do lends itself well to VR. It's sort of, it's almost like you can really see immediately what the application would be when we visualize all the sort of the stresses of the timber lats mount to the actual element itself, and how we really need that sort of that visual feedback as designers on the structural element we're designing. Then yeah, I think the application of VR is sort of obvious.
Okay, maybe that's something we can talk about a little more after Vittorio's presentation, which we'll jump onto now. So can Vittorio join us here? I guess his camera will turn on in a second.
Yeah, so I hope you can hear me and see me.
Yep, loud and clear. Okay, so we're over to you, Vittorio. See you in a minute. Or in 30 minutes.
All right, so I hope you could see my screen. Thank you for the introduction. But I am Vittorio Bava from Mindesk, but Mindesk last year was absorbed by VECTION Technologies. So today I'm going to talk about the solutions of VECTION Technologies in general, and in particular Mindesk. But because we're here at Simply Rhino, that, as the name says, sells Rhino, I think there is a reason why also other products by VECTION Technologies could be of interest. So in a nutshell, VECTION Technologies is a company listed in the Australian Stock Exchange that aims to offer productivity solutions for all the companies that do something physical, from buildings to cars and vehicles and industrial equipment, from the design phase up until the after sales, so covering all the production phases. And we have offices in North America, Europe, and Asia and Australia. We work typically with large companies. Some of those logos that you see probably are companies that you know or work for, maybe. And just to sum it up, we have three type of offers, let's say, for three type of professionals within the same company. We have VECTION Design for design professionals, which is probably what is of interest today, VECTION Sell for marketing and sales, and VECTION Service for line workers. And in each case, the goal is to have a productivity boost that could be declining in different ways in every phase. So without further ado, I'll go directly to VECTION Design, which is what used to be called Mindesk. I mean, it's still called Mindesk, but just for you to know, there is this rebranding happening. Mindesk is a Rhino plugin that allows to visualize, but above all, edit things in virtual reality. So one click, you go to virtual reality, and you can modify things. And this is something unique because All the other solutions out there are visualizers that rely on an export, while this is a native solution. And it's very simple to use. You don't need to learn anything. Basically, only the controller, how it works, is just 3 buttons. And as you may see in the video that I hope you're seeing fluidly, now this user is about to extrude a line, and with all the features of Rhino editing, all the icons are the same, the snaps are the same, and there is also a mirror of Grasshopper, so you can have Grasshopper in virtual reality navigate and operate. Like right now, the user is using the sliders and seeing how the facade of the building is updating in real time. Just to connect with what Giulio was saying, that net of timber that he showed in his project, originated by the Grasshopper script, would be something that you could be modifying in virtual reality. There was no video of that in Giulio's presentation, but just for you to know, that is possible. And this is the, let's say, original main function of Mindesk, but it also added new features along the way. One of these features is the collaboration. So which allows to have more than one user in the same Rhino session. This is particularly useful for the design review phase, because it turns out to reduce the number of meetings and reduce the misunderstandings that happen, all the back and forth between professionals that might be doing different parts. If you can meet in the same Rhino session, if you have to modify something, it's just as easy as doing it with your hands, and then it stays in the Rhino file itself. You don't need to send anything, you don't need to explain anything, or and also being immersed, there is a smaller risk that you didn't see something, some issues, some errors. And by the way, one thing I didn't mention earlier is that Mindesk works with all the other Rhino plugins as well. So to the extent something is in the Rhino viewport on the desktop, you can see that in virtual reality and interact with it. So even if you could potentially do everything in virtual reality, what I like to say is that it's not time to burn your keyboard and mouse yet, because the use we're seeing from professionals is that it's a complementary use. Typically, they do some sketching in virtual reality and then maybe finish things up in the old way, and then doing the design review in virtual reality. In particular, this type of design review with more than one person immersed in the design itself. It is in local area network because of security and speed. So not a bit comes out of your premises, which is frequent concern of certain design professionals. But it is possible to use a VPN, so you can have this type of collaboration also remotely. And I'm going to spill some beans here. We're already working on a cloud version of it. So you could have either Rhino running on a Amazon server or something, like a cloud solution provider, or even have an on-premise server installed at your company. So in that case, it's a completely private cloud with a lot of computational power, and the devices that connect to it do not need to be as powerful to run very complex projects. One other aspect that one type of workflow is the live link with Unreal. I'm about to show you in this video. So this doesn't even need VR per se. It could be used in VR though. So you could see on the left end of the screen, the user is moving a Rhino object, and it gets updated in the rendered version in Unreal. That, of course, works also with Grasshopper. And I hope you could see the window sliders are being changed, the orientation, and that changes the amount of light coming in. Because as you probably know, with Unreal, you could have photorealistic materials and lights and all of this, and so you could just keep working in Rhino and see the rendered version of it. That saves maybe a few minutes of render time, but a few minutes at a time by thousands of times per year, it adds up. So this is why I was talking about a productivity solution. It's not just a marketing tool, a nice to have. This is something that allows you to do more work in less time, and hopefully a better work, because you have an immediate perception of what it does. By the way, it is possible also to have virtual reality in Unreal, and this is used most frequently with a design review session with a client themselves. For example, in this case, what you're seeing, the only linked object is the window, and everything else is the Unreal scene that has been exported from Rhino. But you could keep it, even for more complex objects. You're seeing that now that the user modifies the Grasshopper sliders, the light that comes in and reflects on the wooden wall and the pavement is changing. So a professional could see in a virtual reality, in a photorealistic way, in real time, the changes on the Rhino model. And this is something we're working on with AKT for that project Giulio and Joel mentioned before. So probably there are a few more videos and news about this coming up in the next weeks or months, probably 1 or 2 months, but expect something in that field. So to sum it up, you could have either the virtual reality directly from Rhino in shaded mode, or virtual reality in photorealistic mode through Unreal, or Rhino Unreal even without virtual reality. Just to complete, I'd like to show you this video that we've shown in the last webinar with Simply Rhino. It's about one trick that it is possible to do, which is asset mapping. In this case, you have Rhino on the left and Unreal on the right, and to each dot generated with Grasshopper, we assign an Unreal asset, a specific type of tree. For specific type of dots, those are assigned through this text box in yellow. And the way to change it is as simple as copy-pasting the asset name from Unreal to Grasshopper itself. So you're seeing the user is changing the line that originates the dispersion of trees, and it gets updated in real time. If it is maybe 1 or 2 seconds, if there is 1 or 2 seconds of lag, it's because this one was 150 million polygons on a laptop that was like 2 years old. So once again, this workflow is thought with performance in mind, and is thought to save time and do things quicker. And perhaps now it's going to be visible how easy it is to change one asset. Now the user just substituted dry trees for one specific type of dots, and it is going to be visible as well how easy it is to keep working on Rhino, really not change your workflow, but have the render immediately. I hope you're seeing the trees that are popping up as soon as the object is created in Rhino. And the same goes for orientation and everything else. So far, I mean, the number of architects using Unreal is growing really quickly. it should be around 600,000 architects, and I presume some of you is probably using a real already, so maybe this is of interest to you. Then another big news from 2021, we're also compatible with Vario and Microsoft HoloLens 2, which means that now you can have Rhino editing also in mixed reality. So sometimes users would say that virtual reality could be isolating a little bit, even if that is a feature. Sometimes you want to be isolated. But in this video, you're seeing the user is having a scaled down version of the car he's editing on the desk, and you can see he's changing the Grasshopper script, doing the rims and the rim change in real time. But you can also put that in one-to-one scale and see it. This video is about a car, but if you think about houses or let's say architecture in general, you could be on site modifying a Rhino model that has been overlaid on the site, and you would see immediately if it fits or not, or what are the effects, what are all the layout issues and all those things on a one-to-one scale. You can also change it, but you get the point. Now it is possible to work in Rhino in augmented reality with all the Rhino features. And so to sum it up, Mindesk is used for sketching or design, virtual design and virtual design review. That could be also collaborative. And the advantages are to have a clear perception of spaces and proportions, to design with your hands rather than with the mouse. Everything comes more natural, to have this unmistakable communication with colleagues because you're both visiting the same place and seeing things with the same eyes almost. And so you can reduce the number of meetings, reduce the number of prototypes, and have a quicker design cycle that sometimes is what allows to win certain competitions, and reduce also the travel and save all the rendering time that usually it takes to work with render solutions. Now, I would like to spend a few minutes to talk quickly also about the other solution that VECTION has. One of them is VECTION Cell that now comprises FrameS, that is a visualizer by VECTION. The difference with Mindesk is that FrameS works with files that have been exported from Rhino, either in FBX or OBJ format, and it has a plugin that does that automatically. So there is another Rhino plugin available for you. And the purpose of FrameS, though, is not to edit things in virtual reality, but just to look at them. So to perhaps move them around, but whatever modification you're doing it to the OBJ export, not the Rhino file. So that is a tool that is thought for showrooming your designs and in general for selling purposes, or let's say presentation purposes. It's the virtual version of PowerPoint. Let's put it like that. And it can be used collaboratively and also remote with remote users, up to 6 users. That could also have voice chat. So it will be like meeting in the virtual space. And another thing that could be of interest to the audience, that I presume is made mostly of architects and interior designers, is that there are also configurators, or let's say in general solution of augmented reality that work on mobile devices. In this case is a furniture configurator, and in augmented reality you can select all the materials of the object and then see that in augmented reality. So for the ones of you who are into interior design, that is something that now is also available. So to sum it up, VECTION Cell is for selling, as the name says, It's for internal collaboration, but mostly for showrooming, configuration, and in general sales and marketing. And the advantage is that it involves the client into an emotional experience, and simplifies a lot the selling management and processes. And one very quick word also about VECTION service, because to the extent that you might be involved in the construction as well, there is this virtual solution that is thought for training purposes, safety training or operation training. Imagine, for example, in this video that you're seeing, that if you do things wrong, you get run over by the bulldozer. That's a traumatic experience that's going to leave an emotional scar that perhaps is going to reduce the number of injuries on the site. Why is that of interest to you as architect or engineering professionals? Because if you have a more effective training and you have less problems on the construction site, you have a less chance to have a delivery project slippage of. And all in all, I mean, it's important to have a safe working place, even for people who are not really in architecture, but they're building the house or the building with hands. That concludes my presentation. I tried to be quick because I wanted to leave some space for Q&A, because since I've said something new today, I presume there is going to be a few questions. So if you have any, I'm all yours. I'll leave the screen sharing on because maybe we want to go back to certain videos or images.
Okay, thank you, Vittorio, for that. I don't know if the guys from AKT II could also join us, that would be great. But I will adjust a couple of questions. Right, somewhat question from Henry. Is it possible to edit a design in Mindesk using the full features of the keyboard mouse? Essentially replace the monitor with a VR headset instead of using cumbersome hand equipment. I'll
answer that. So first of all, it might be debatable whether that is cumbersome or not, but that's exactly the principle that animates us. One clarification, so even if in principle you could do anything you do in Rhino in virtual reality, because of space and also time, we put in 50 or 60 functions, the most used functions. So if you need some, let's say, exotic function, you can still go back to the desktop and do it. But hold on, that is for virtual reality. If we go to the augmented reality version, which is when you don't get to isolate yourself, something interesting happens that it is worth mentioning. I'll show it here, and I'll freeze the screen when that does. So Vario has a Retina resolution headset, which means that to the human eye is exactly the same. So what certain users are doing is they're having a virtual monitor with Rhino, so a mirror of the real monitor, and they have the keyboard and mouse, and they keep doing things with keyboard and mouse, but then they look on the side and they see the house or whatever they are creating. So to the extent you do that in augmented reality, that is absolutely possible to keep working with mouse and keyboard. I hope that answered your question.
Yeah, and Henry, let us know if you have anything else to add to that. But by the way, if there's anyone in the audience that wants to speak to anyone, wants us to unmute them so they can actually ask some questions, this is completely possible as well. So, you don't have to type stuff in if you don't want to. If you want to talk to somebody here and just ask a question, you'd be welcome to do that. Just let us know. Okay, from Porus here, a question. May I know if Frame S and Configurator, is this part of the Mindesk plugin application, or is this something separate?
It is something separate. I presented it today because FrameS has the Rhino plugin that exports the file in an optimized way to FrameS itself. So it's a separate solution. If I could say that again in a maybe more concise way, Mindesk is the solution for architects and designers. FrameS is the solution for commercial personnel, and VECTION service is the solution for construction personnel. So they're thought for different types of professions.
Okay. Okay. Also, there are some more questions coming in, but there's also, you know, the opportunity. I don't know if there's any questions between the two presenters. You know, yes. Okay, Julio, please.
No, I was really thanks for the presentation. It was really interesting, and it's crazy. Like, it's gone such a long way from the sort of the old days of having to export files and having to bring them in the various platforms. And so my question was about the Unreal Link. So how much do you actually have some metrics of how much that gets used versus the sort of the Rhino shaded viewport sort of export, that, and then about the Unreal Link in general, whether sort of you were mentioning the sort of bidirectionality. If could we get an idea of the sort of the extent of those features, or sort of what you're planning, what you have in the pipeline for that,
and when we can use it? Yes.
Yeah, well, that is a bit risky to answer in detail because I'm aware it might generate expectations. But I'd like to say that we know that design professionals would like to have everything working with everything as realistic as possible, and so what is the dream that we keep hearing from architects and design professionals is that they would like to be in the house, see if it was real, and when they change things in the most simple way, even with vocal commands, for example, or even thought commands, you can have the circles in your head that do brain scanning and have an electronic input to see that happen. So that is the goal. We're aware of that. We're working toward that, but it's going to be paced, right? So we did Rhino virtual reality in shaded mode, and we did that with the performance in mind. Now there is the Rhino Unreal Link that is, for the moment, is sort of a one-way thing, but I'm gonna spill some beans here. We already have a prototype of something that might work in two ways. It's something we're working with AKT, and so it is fair to expect something in that regard, but it's a bit too early to give any details about the product itself or the time. One thing I could tell you is that as soon as we have that, we're gonna give that as a private beta to our existing users. So there you have it. One more reason to become a Mindesk user is because you would see these things in advance. And another half a secret that I'm ready to spill is that we're working with there might be some integration with Revit coming in some time, but even that is going to be something that is going to be given as a private beta to existing users. And since I presume most of you might use Revit, that's another reason why to sort of be in the loop before the rest. I hope that kind of answer your question. I've not been vague, but please be understanding that I couldn't be more detailed.
It was a bit of a trick question there. Didn't want to get you to tell out too much. No, I think the other thing.
Prototype of that.
You mentioned FrameS and Cell are sort of, yeah, they're sort of more focused towards the sort of not necessarily the designers. But I think it sort of opens an interesting question, especially in these days where we are so delocalized from our offices and sort of all collaborating remotely, whether that actually could have an application in the design phase where we are collaborating virtually in early stages of the process, effectively replacing our DTMs or workshops in each other's offices. No, it's not really a question. It's just sort of I guess just a general point there to make, and I'm just wondering whether that'll be the case in just a few years' time.
Well, it depends where you want to meet. If you want to meet inside the Rhino file, then you would use Mindesk, and that is already possible today. If you want to meet in the nice-looking export, then you will use FrameS. I hope that adds something.
No, exactly. Yeah. I think could work.
Yeah. Okay, Vittorio, a couple of questions. Okay, can you see or use Mindesk AR model with two devices from one Rhino session for designer collaboration?
Yes. Yes. The AR devices have to be sort of calibrated in the same room, but yes, you would see the same.
Okay. Okay,
because
great.
if there is a miscalibration, maybe the one user would point at something and the other user would see the hand going somewhere slightly off. So, but once you calibrate, well, if you're in the same room, so it should be working. I say should be because, of course, it depends what you do. I cannot say in advance, but in principle, that is possible.
Okay. That was a question from Mikhail. Let us know if you have anything else that you want us to ask. Someone's just saying, where do they find, I guess it's where do they find more information on FrameS, I guess, or where to find FrameS. It just says, yeah, I guess that's on the VECTION Technologies website.
Indeed, it's vection.com.au. Okay,
so there you go for that one. What is the impact of the live link in terms of hardware? Is it possible to run and edit a heavy architectural model, for instance, that may be running well with mainstream hardware? And I guess, yeah, something like a machine with 64 gig of RAM, an RTX 3080 card.
Well, if you have a 3080, with performance in general, the more the merrier. For Mindesk itself, the VR version, the shaded mode VR, basically you lose the sensation of having a ceiling because it's really, really optimized for performance. However, Unreal is a little bit more taxing on the machine, so there's gotta be a limit somewhere. For what I show you in this video was 150 million polygons on a 1060 graphic card, which is years behind the 3080. So there is no software limitation in that. It's a hardware limitation. So if you have a 3080, you should be able to handle pretty complex project. If you start to hit the ceiling because you see is starting to lose frame rates or it crashes or whatever, then you need maybe two 3080s or you need a bigger computer in general. But that's just a hardware issue. It's not a software
Yeah.
issue anymore.
Yeah. Is there any good sort of reliable benchmarking, particularly aligned with your app rather than generic reports? Have you done any specific benchmarking tests?
I'm not sure I got the question, but if you want to know if there is sort of a ladder of a certain graphic card with a certain number of polygons, well, we sort of have an idea, but there is not one single metric. So it's not just the number of polygons. It could be there are a bunch of metrics that can influence the performance. In general, I could tell you what happened with the same file. It was a vessel, a naval vessel. There was 1.5 gigabytes, 7 or 10 million polygons. With that file, if that could be of any indication, a 1060 graphic card was starting to struggle. I mean, it was handling it, which is already remarkable, but it was struggling. A 2080 graphic card was going at 10 or 15% capacity. So what the 1060 was 100%, the 2080 was 15%. I haven't tested on the 3080, but probably like 6-7%, or something along those lines. I don't know how many of you have multi-gigabytes Rhino files with tens or hundreds of thousand polygons. Probably a very small percentage of you. So to the extent that you have a file that is in the tens of millions of polygons and is maybe less than a couple of gigabytes, modern graphic cards are absolutely able to handle it.
Okay. Okay, thank you, Vittorio.
I hope that answered your question. Yeah.
I think so. Thank you. There's just a couple more questions here. Right, from Matt. Can you compile Grasshopper scripts used in Mindesk into standalone functions where Grasshopper doesn't need to be opened?
I'm not sure, but I would say no. But what you could do is you pack the Grasshopper function to one single toggle button, and then from virtual reality you click on and off of that, and that would be one way to have that function, I suppose. But I don't know if the user can answer, but would that be for some sort of animation or something like that?
Yeah, I think Matt would need to know what sort of thing what problem you're trying to solve. A bit more about that. Let's see.
Well, there's something I could add in general is that we try to be as universal as possible. So to make everything work with everything all the time, if that could be sort of a generic principle. So if you had in mind something specific, please voice it out. But in general, everything should be possible until maybe we find the exception.
Okay. There's a general sort of question about the future of Rhino and Grasshopper, but question from VRL, could it be that in the future Rhino and Grasshopper together become more than Revit or products like ArchiCAD? And I think that's really, I'd say no. What you're going to see happen there is that projects like Rhino Inside will allow the products to work much closer together and in a more integrated fashion, sharing elements of a UI like Grasshopper. So you get the amazing geometry kernel of Rhino, for instance, driving a great BIM documentation tool such as Revit. So that's kind of more likely, and the same with ArchiCAD. There certainly isn't the intention for Rhino to become its own kind of BIM solution and and take over in some way. That's not on the cards. Okay. Anything else here? Right. Last question. Okay. Right. It says it's better to work the virtual reality in Rhino, or we can do or would we experience better performance in something in perhaps Unity using Unity Reflect? Is that something anyone has experience of?
I would tend to say Rhino, because the graphic engine that we're using in the Rhino shaded mode in virtual reality is designed specifically for that, is hyper optimized to do just that. And so, I mean, I haven't tried specifically with Unity Reflect, but I'm not sure they have the same amount of focus on making things go faster that we put in. If there is one, I could brag about two things on Mindesk. One of them is the fact that the UI is designed specifically never to get you sick, and the other one is that the performance is purportedly made to be fast, right? It has to be as fast as it gets. So if performance was your concern, I would feel pretty confident that there is no faster thing than Mindesk at the moment, that the shaded Rhino mode in virtual reality. As long as we're talking, as far as virtual reality goes, that is the quickest way.
Okay. Okay. And just next steps. So next steps for someone who wants to trial Mindesk. Visit the website, contact you. What would you?
If I were in the audience, I would contact Paul to have that. But if you want, you can download the trial version. It's free. You could just get it on the website. Just sign up and get it.
Okay. Well, if there are any questions that we've missed by anybody, I hope they're not, but there could be, and we will respond to you by. Sorry, I'll just get this. Just to thank everybody. Thank you, guys. Joel, Julio, thank you very much for your presentation earlier. It's fantastic. Vittorio, thank you very much. I just want to say thank you as well to our sponsors. We have two sponsors for these meetings. PNY, first of all, and they're the distributors of Quadro cards that have got a few mentions tonight of the nice solutions for driving these products. And Beam, Beam are a third-party developer. They have a very nice, elegant solution for moving Rhino data into Revit and the other way. So it's not an alternative, I would say, but a similar to Rhino inside Revit, but a simpler approach, let's say. Okay. Now, we don't have dates for our next meeting yet, but we, of course, will be back to everybody with news on our next meeting pretty soon, within the next few weeks. We look forward to seeing everybody again soon. So other than that, thanks everybody for joining us. I hope you enjoyed those two presentations. Thanks again, guys.
Thanks, everyone.
Thanks, bye.
Bye-bye.